Learning objectives. We're going to define a few terms here. We're going to look at classifying, graphing, a little bit of graphing, and then describing end behavior. So here's some vocab to know. Polynomials consisting of several terms. Here's an example. Some non-examples. If the square root, or if the variable is under a square root, that's not a polynomial. If the variable is in the denominator, not a polynomial. Those are non-examples. Okay, all the exponents must be whole numbers, and they're positive. Okay, so you can't have something like x to the negative second, not a polynomial. Okay, so exponents must be nice whole numbers, no fraction exponents, no negatives, nice whole ones. Okay. Degree is the highest exponent when you look at each term separately. So here, and this is in one variable, the greatest exponent is 8, so the degree of this polynomial would be 8. Standard form arranges from highest to lowest degree. So here's an example of that. So if we had this particular polynomial we want to list in standard form, we would start out with the 8, the one that has the term that has the greatest exponent, so negative 4x to the 8th. And then we just kind of walk it down. Arrange them in order. Turning points, where the graph changes direction. Turning points could be maximums and minimums like we have here. They could also be something called an inflection point. So if we look at this one, it goes up, gets to this point, and comes down. So we're like increasing, and then we're decreasing. So this would be a maximum. And then we would decrease till we get to this point, and then now we're increasing. So this is a minimum. And then we do it again, right? This would be a maximum, and this would be a minimum. Those are turning points. The other one that's a turning point is something like this, where the graph is increasing, and then right around here, it kind of looks like the graph turns, sort of turns a little bit right here, but we're still increasing. This is what we would call an inflection point. And these are both turning points. In general, the graph of a polynomial function of degree n has at most n minus 1 turning points. So for instance, back to this example, it has 4 turning points. So that would mean that the least degree that this polynomial could be would be a degree of 5. And we're going to talk much more about that in depth a little bit later. We're going to do this discovery activity with our calculator. So don't worry too much about it at this point. End behavior is the direction on the end of the graph. So here's some examples. This one's pointing down from left to right now. So this is the one on the left. So down. And then over here on the right, we're pointing up. On B, it's down and down. Here we're up and down. Here we're up and up. There's our end behaviors. You can classify polynomials by its degree and or the number of terms. So if we have one term, it could be anything. This particular one is a 5. One term, we call that a monomial. 2 terms is a binomial. 3 terms is a trinomial. 4 terms, we just use generic polynomial. Okay? Remember, terms are separated by plus signs and minus signs. Right? So, for instance, 1, 2, 3, 4. That's how we're getting our number of terms. Okay? Over here, we can classify by the degree. We're looking at the exponent. So this one doesn't have a variable or an exponent, so this is a degree of 0. So it's a constant, just a regular number. Here we have a degree of 1, so we call it linear. Here we have an exponent of 2, which we talked a whole lot about, right? Quadratic. Here the highest exponent is a 3, so it has a degree of 3. So it's cubic. And a degree of 4 is quartic. All right. Now, some parent graphs that we're going to be looking at. And we're just going to go ahead. I'm going to go ahead and draw a couple of these for you. Here's some parent graphs. We can have a line, right? Here's some parent graphs. I want you to be cautious of their shapes, all right? And I know that these aren't the best, but a linear equation, the parent function is y equals x. It goes through the origin. This one's a little bit off. It goes at 1, 1, negative 1, 1. Linear functions are always lines. A quadratic, the parabola, we've talked a lot about that, y equals x squared. A cubic function is going to have this general shape, okay? And then a quartic, something to x to the 4th, is going to kind of look like a W. Now, we can do a lot of things to any of these graphs. We can do some transformations. Like what would happen, for instance, if we put a negative out front of this? Wonder how the graph would change. What if we put a negative out front of the x squared? You should know what happens there, right? It flips over the x-axis. Well, the same thing's going to happen if we put a negative out in front of the x cubed. It's going to flip over the x-axis. So maybe sketch what that would look like. Pause this and sketch what that would look like if we put a negative in front of x cubed. Okay, what if we were to add a number out here? X squared plus 2. That would raise our parabola up 2 spots. You already know that. What would happen if we do plus 2 here? Well, it's going to have the same effect. It's going to raise it up 2 spots. So you already know a lot about those transformations. Okay, well that ends our little video today. Make sure that you go back and fill in your Google form for credit. And I'll see you in class next time. Thanks. Bye.